So when does it take up? 3:45?
Yeah, we got 2 minutes and 25 seconds.
Well, we have to watch
until they
this.
start up.
So here soon.
We have to watch this. In the meantime, while we're waiting, go ahead and load that up. So that'll help you now. Reduce the tension.
And they're going to take
If you haven't already loaded it up.
Yeah. The professor, the activity wants to use Thursday.
Yeah, I'm gonna make an announcement. Don't worry about it. So where will you see it from? Where are we looking?
They're all standing like on that
Okay.
walkway.
It's going to be kind of more southwest than here, or southeast from here.
I saw the last one. I was out on A1A. It was really beautiful. It was like a night.
I've seen 90% of them from my backyard, so
That's cool.
because I live out in the land.
So do I. Yeah.
Lake Helen.
What's that?
I live in Lake Helen.
Okay.
So
I'm up in New York.
yeah, I'm all the way out in Lake Helen, so I just say the land because most people in the area know where that's at.
Yeah. Right.
How will we know when our group is submitted the assignment form?
I'm gonna make an announcement on that. Don't worry. We'll definitely talk about that. So do they have like an app that does the countdown or something? Is it,
No, I'm watching it on the live stream.
Yeah, they got a live stream going on now on
Let's see.
YouTube.
On YouTube, they just started to start up.
Did you say 50
cool.
seconds?
They've initiated
47%.
Why is yours 2 minutes?
It's too long. One of my friends is actually the platform chief engineer.
Oh, that's cool. I want to watch that. And it's someone for a boss is like, I would never say
No.
Yeah, that the whole system.
You didn't need to see it.
And we screw up all these things out like that.
Yeah.
Too much for me.
I mean, it's something cool, right? Like, it's not like you see it every day.
Wow, yeah.
Oh, we started it. Oh, there it goes. Ignition. Oh shit, that's actually good.
Just a really nice blow.
5 months to say it blows up.
Can I see the full?
Yeah, let's do it.
Wow.
This is beautiful.
Yeah, we see this like acting like that.
It's like actually right there.
Oh, look, I'm looking out there. Actually, looking out the other way.
Yeah, it should be that way.
I think it's gonna be over here.
Alright. You're not gonna be able to see much of that. Yeah.
I'm up.
Fuck it, I'll see another one.
Yay, it's up.
See, are you saying anything?
Wow.
How long will it take, do you think, to get here? What's that? it's a probability question. Yeah, like that could be.
It's fine, you're
They have like a little
talking
timeline.
about Snapchat about it.
Yeah, right?
Let's see.
I just want to see it
More
more.
over that way, so we're not gonna be able to see.
Okay.
If my memory.
I guess we're out of the line of
I
view.
think it's like literally right there.
So.
My line of view is not the best.
No.
Yeah.
Sorry, that's what we have on freaking live stream.
Yes. Live stream laptops.
I just think it's hilarious that actually have a Tesla.
Oh.
Oh yeah, just don't worry, we won't have too much
Hey,
money
guys,
inside,
this
just
is
put one
my
card in. Because it's the most powerful
So
one we've ever launched.
we'd be seeing it by now, wouldn't
By,
we?
Yeah, they're already all seeing it.
You should be able to see it.
All right.
Beautiful.
Oh well. Okay.
It's purple.
So anyhow, okay. So let's snap back into class, okay? So there were a couple of questions. Okay, I'm gonna start now. We really want to get through this stuff today, for sure. So the way I'm gonna probably focus works out is that everyone can turn it today. If not, feel free to turn it on Thursday. Okay, but I want to go through the results in class on Thursday. You can just email me that document. All I need is just one submission per group. Okay, so pretty straightforward. All right. Any other questions we have or things we want to discuss before we take off our class? Okay.
Oh my God, I was blocked by space travelers down there.
I know.
Yeah, no.
Okay, so here's kind of the idea. Here's where we've been, and here's where we're going. And I want to kind of piggyback off of activity 1. So what we've been talking about are data sets. We've been making plots of data sets, right? And kind of the idea is that we really want to get what the population plot looks like. So we have these data values, we're plotting them, and we're getting some sort of histogram of the sample, right? Maybe the sample looks like this. And let's just suppose this was the building size, okay? So we kind of use our activity 1, okay? So this is from the sample. Maybe the sample kind of looked like this. This might have been the computer sample, right? So the average for the computer was like 7.55. And we said, okay, we want to describe what this plot looks like. So one of the things we're interested in is we're interested in the center, which we're going to take to be the sample mean. That's x bar. And kind of the idea is what we're trying to do is we're trying to compute attributes or properties of this plot that estimate what the true population looks like. So the true population maybe looks something like this. And we found the population mean was like 7.65. So this is the population. And so we want to try to compute numbers that are going to describe this plot. The two main things that are going to describe this plot are where it's centered, right? So that's the mean. So the center for the population is going to be the population mean, or mu. And this is an example of a parameter. This describes the center of the plot for the population. Okay. Now, okay, guys. Don't worry your crap, all right? Now, one of the things we saw last class, we saw that the center was not sufficient to really describe what was going on. In that example were the two shooters, Jack and Jill, right? They had almost the same center, and yet they were very different. Jack was really all over the place. Jill wasn't. So besides just describing the center of this plot, we also need to describe the spread too. That's also important, right? So the second thing we want to do is what we want to talk about today, which is the spread. So we're going to talk about how do we compute a number that's going to characterize how wide this data set is. And it turns out that just like with the center, we had two different measures for the center. We had the median and the mean, right? We're going to have three different measures for the spread. And that's what we want to look at today. So we're going to look at these things that are sometimes called measures of dispersion. When things are dispersed, they're spread out. So this is measuring how spread out the data set is, okay? So we're going to introduce these three different measurements for how spread out the data set is. The first measure is called the range. Very easy to compute. We're going to take the largest data value, okay, subtract it from the smallest data value, and that's the range. So basically, it's giving us the length of the interval that contains all the data values. Now, here's the pros and the cons. Myself, I always compute the range. If for no other reason than the fact that in order to compute the max and min, you have to order the data set. When I order the data set, I'm going to be able to pick out outliers. And if there are outliers that are invalid data values, like I'm looking at people's heights, and I get a height of 9 feet 8 inches or -5 inches, I can pick out invalid data values. It also gives you a sense for the values that the data can take on. You always want that, okay? So even though we don't use it as a measure of the spread ever, we almost always compute it. Plus, it's easy to compute. Now, here are the bad things. First of all, we talked last time about how we don't like things that are going to be really sensitive to outliers. We don't like the idea that something we're computing that characterizes the entire population, everybody, is really sensitive to a few values. And if you think about it, the range is incredibly sensitive. It takes the most extreme values, right? So it's going to be very sensitive to outliers. It also doesn't use all the data. We don't like that. It's really only using 2 data points and excluding everything else. If you look at these 2 different distributions, right? This is uniform. This is skewed, less skewed, and yet they have the same range. So there's a lot of information the range doesn't include. So for that reason, we're not crazy about this, okay? As a measure of the spread. So let's go ahead and compute the range for Jack and Jill. This is pretty easy. For Jack, here's the data values. They're organized, right? They're ordered. And if we go ahead and take the largest data value minus the smallest, we get a range of 11. For Jill, again, to order the data value, take the largest minus the smallest, we get 1.6. And that's a pretty accurate representation of what we saw, right? Jack was all over the place. Jill had a really tight cluster of shots. So this kind of reflects that, okay? Now, here's the thing. Even though it's really easy to do, we don't always want to do it. First of all, you have to order the data values. And secondly, a lot of times data values are really a pain to work with. What if they have 4 decimal places? Do you really want to do this computation? I don't, okay? So we're going to use StatCrunch. So go ahead and open up StatCrunch, and I want you to download that data set for the Cadillac and the Saab. And we're going to see how to go ahead and compute the range.
So,
yeah.
I'll try to get StatCrunch.
I'm sorry?
Try to
And you guys can work together if you want to work together. So please open up StatCrunch now. This class is all going to be about hands-on, okay? Everyone has it downloaded. Are you working on it? All right, good. All right. And all we're going to do is we're going to go to stat whenever we want to compute a statistic. Remember what a statistic is? Anything computed from data, right? So I'm going to go to stat, summary stats, and columns. And so when you open up the data set, you click on stat, summary stat, choose the column. Then you're going to open up this window right here, working. Okay? Yeah, feel free to work with it. Once you kind of see it, it'll make perfect sense. It'll be easy, okay? You're going to open up this window here, and then you're going to go ahead under column. You're going to basically tell StatCrunch what variable you want to compute, right? So I want to compute the variable that's in the column that's called price. And I want to compute things for both the Cadillac and Saab separately, right? So I have a categorical variable here, make. I want to compute statistics separately for the Cadillac and Saab, so I'm going to group my statistics by make. That'll compute the statistics for the Cadillac and the Saab separately. And then finally, under statistic, I'm just going to choose range. That's all I'm going to compute. Okay. So here, I'm gonna play along. Open up StatCrunch. And just import the data. And chances are you already have it loaded. So this is where saving data sets really comes in handy. Okay, I'm just going to load from my data because I've already saved it before. And there we go. And now we're ready. Stat, summary stats, columns, price, make, and just go down here and pick out range and compute. Those should be your values, right? Stats, summary stats, column, price, make, and the range. Okay? I want to make sure everybody's getting this. How's it looking? Pretty good? Good, all right. Okay. Excellent. Okay. Good, thanks. All right. So you notice what this tells you. This tells you that the Cadillac has a huge range, right? What is the range for the Cadillac? 40. Right. So that's like the price of a car, right? That's the range in values. It's huge. The Saab about 16K. And that's kind of consistent with what we saw. If you remember the data set, right? The Saab had that. Saab was nice and symmetric. Cadillacs were all spread out. Good. Okay. And that's the range. Like I said, it's nice because it's really easy, right? Okay, so now we want to go back and look at the other one. Okay. We've done the range. Now I want to look at what's called the standard deviation and the variance. And essentially, all they do is they tell us the average distance from the data points from the mean. So you think of the mean as kind of like home base, okay? And you're basically calculating on average how far are you from home base. That's the idea, right? The pros and the cons, there's actually a lot of pros. We're going to see that the standard deviation is a really important tool in statistics. But for right now, we're just going to make the observation that it uses all the data. So here's kind of the picture for the standard deviation. We have some data set, okay? Yeah, just maybe draw some little dot plot, right? We think of the mean as kind of like home base. Okay, this is the mean. It can be the sample or the population mean, okay? This is kind of like our home base. And what we're doing is we're just calculating the distances of all these data points from the mean. And we're in a sense kind of calculating the average distance, all right? So you can see, first of all, it uses all the data. It uses all the data because it's using the mean, which uses all the data. But then we're also calculating like the average distance from all the data points from the mean, okay? Now here's the bad thing, is that it's very sensitive to outliers and skews, because what happens with outliers and skews? What do they do to the mean? They pull the mean out, right? So what's happening is your home base is getting pulled away from most of the distribution, and that's going to cause the average distance from the mean to increase. It's going to inflate the standard deviation, okay? That's one of the cons. So how do we do it? Well, we got to be a little careful, because notice that there's a population and there's a sample standard deviation. So in other words, there is a width of the data set from the population. Okay, we're going to call the population standard deviation sigma. It's just a Greek letter for lowercase s. This is the formula, and we're not going to really use it a great deal, but it's important to kind of notice that this is the deviation or the difference between the data value and the mean. We're squaring it. We're adding up all those squared distances, and we're taking the average, right? Dividing by the number of data values. So it's like an average distance from the mean. Notice that sigma is a parameter. So sigma is a number that's characterizing the width of the population, right? So we have the population standard deviation. And this, again, is another parameter. It's describing the width of the population values. So these are both parameters. The population mean is telling us where the center of that distribution is for the population, and the population standard deviation is telling us about the width of that plot for the population. They're both parameters, which is bad news, right? Because it means that we generally can't get that. That's another target value, just like the population mean. We want it, but because we can't get at the whole population, we generally can't get it. So what do? Take a sample. Right? We estimate population things from samples. So we have a sample standard deviation. That's denoted by S. Notice they start with the same letter, okay? This is just the Greek version. So now we have the sample standard deviation. Where did my black one go? Here it is. So my sample standard deviation is S. And sometimes we just abbreviate standard deviation like this, STD, DEVTN. That's S. And that's characterizing the width of the sample, telling us the average distance of the data values from the sample mean. So not too surprisingly, this is what the formula looks like. There's a little difference though, it's not quite the average. Instead of using n, I use n minus 1. There's theoretical reasons we won't get into why we're interested in that. Okay? Again, it's a statistic, something computed from data, right? These are all things that are computed from data, and it's used to estimate sigma. So this slide, you should kind of compare and contrast this when we talked about the mean. We had the same sort of slide from the population mean, the sample mean, right? The same thing, population standard deviation, sample standard deviation, okay? So let's go ahead and see how to compute this. Before we do this, I want to say one word about the variance really quick. So the variance is the square of the standard deviation. Okay, so the population variance, I'm going to take the population standard deviation and I'm going to square it. And for the sample variance, I'm going to take the sample standard deviation and square that. And the variance is a really important aspect of statistics. I mean, if you took more statistics, we'd see this come up a lot. But as far as a measure for the width of the data set, it kind of is not that great because it has the wrong units. Okay? We want units that are linear, and this is going to have units that are squared. Okay? So unit-wise, it's not going to be really useful. So let me just show you how to compute this for the Jack and Jill data set. And we're never going to do this by hand except for really small data sets, because this is way too tedious. So first of all, let's look at Jack's data set. So these are the data values. And the first thing I have to do is I have to find out where's home base, where's the mean, right? So I take the sample mean, I get 0. When you add these up and divide by 4, you get 0. And then I look at this thing called deviation. So when we talk about deviance or deviation, we're not talking about perverted data sets, right? We're talking about how much it deviates from the mean, okay? Well, in this case, it's easy because the mean is 0, okay? So these are the deviations from the mean. I'm going to square those deviations, right? So minus 5 becomes 25 and so on. And then I'm going to average them. Okay, almost. Because I'm in the sample, instead of dividing by 4, which is what I should do to average the square distances from the mean, I divide by 4 minus 5, 3. And I get 34 seconds. Now you can see why this is a bad measure for the spread. Because the units is an area, right? Centimeters squared. I don't want that. I want a length, right? So the variance is not a good measure for the spread of the data set. So I take the standard deviation, which is the square root of the variance. I get about 5.83. So let me ask you a question. How do we interpret that 5.83? What is that? We said the standard deviation was like the average distance of the data points from the mean, right? So is 5.83, does it look like the average distance of those data points from the mean? Bless you. Sure does to me. If you look at this, the mean's at 0, right? These data points are all roughly about 5 to 5.8. Okay, from the mean.
It has an IC6.
What's that?
If I'm not mistaken, it has an IC6.
Right. You can never be further. You can't be your standard deviation can't be more than the distance from the mean to the largest deviation basically, which here is 6. That's right. So it has to be between 4 and 6. But the main point is that you can see that the average distance of these data points from the mean, from 0, is around 5.8. So that kind of makes sense, okay? That interpretation. Now, without even looking at Jill's data set yet, should her standard deviation be lower or larger than Jack's? What do you think?
It should be lower.
Okay, and why would you think that?
They were closer to the target, or to the bar.
Right, so we know intuitively that her data set wasn't as spread out, it wasn't as wide, right? And that's what the standard deviation is measuring. It's a measure of the width. So the average distance of her data values from the mean should be smaller, so her standard deviation should be smaller. And sure enough, if you were to go through all these, and I won't bother to go through the details again, her average here was 0.2. You take the distance of the data values, these are the deviations, you square them, add them up, divide by 1 less than the sample size. Again, variance is not a good measure for the spread because it has units of area, not length. I take the square root, and sure enough, I get 0.83. And again, this makes sense. If you look at the average distance of her data values from 0.2, 0.83 is pretty representative. This distance here alone is 0.8. This distance is 0.8, and the other one's kind of average out. Okay, so this makes sense. And again, her data set's not as spread out, so the average distance is going to be low. That's the idea. Okay? All right, so let's go ahead and do this in StatCrunch. Now, here's the really quick hack. Rather than repeat everything, what's kind of the quick way? Does anyone know the quick way to do this? Chase is to go back to where you computed the range, okay, and just click Options Edit. And now all you have to do is just click on standard deviation. Okay? And compute that. So when you go into options edit, essentially that just lets you change that one little option, what you want to compute. Let's see, how are we looking for did you die? Do you want to look out with someone else? Good, go ahead. That's fine. Okay, so how are we doing? Standard deviation's looking good? Okay, good. Do those values kind of make sense? Well, how do we interpret them? How do we interpret the Cadillac value? What is that telling us? It's telling us that the average distance from the mean is about $10,000. For the SAW, the average distance from the sample mean is about 3,500. Okay. And that makes sense. Distribution wasn't as wide. If you're not as wide, you can't go as far from home base, right? So your average distance from home base is going to go down. All right, good. So any questions on mean and standard deviation and variance? And we didn't bother computing the variance. Again, we're not going to use it a lot unless the book asks for it explicitly. Okay. Now, one last measure we want to present is this thing called the interquartile range. So, kind of go back and remember from the box plot, right? We were looking at the quartiles. So Q1, Q is like a quarter, right? It's like we have one quarter. That's the 25th percentile. That's the first quarter of the data. Q3 is like 3/4. That's the 75th percentile. And so what is the interquartile range? Well, it's defined as the difference between the value of the third quartile minus the first quartile. And that's the abbreviation we use. Now, what is it? Okay, we're always trying to figure out what are these things that we're computing. We have an interpretation for the range and the standard deviation. It turns out this has a pretty cool interpretation. If you think about it for a minute, this is the first quartile, okay? 25% of the data values lie below it. This is the third quartile, 25% of the data values are above it. So this is the middle 50%. And so this is just like its name says. Interquartile range. It's the range between the quartiles. Interquartile means between quartiles. So this is telling you the range that contains the middle 50% of the data. Now you might say, well, why do you care about that, okay? Well, one of the things we're always interested in statistics is we're always interested kind of in the majority of the population, okay? And so this is basically kind of like the masses, right? This is kind of like the middle 50%. And kind of the pros and the cons behind that is that because we're only looking at the middle 50%, it's not sensitive to skews or outliers. It doesn't see what's going on in the tails because it's not looking at the tails. It's looking at the middle hump, right? And it doesn't see the outliers at all. The outliers are totally outside. So this is good. This means that this is really insensitive. But it's also bad at the same time because it means that it's not using all the data. We're losing this data in the tail. If you have a data set that has a hump and a really, really long tail, the interquartile range is not going to reflect that, okay? So there's good and there's bad behind both of these. Okay, let's go ahead and do the computation. Again, the quick hack is just to go into StatCrunch is it actually lets you compute the interquartile range directly. You don't have to compute Q1 and Q3 and subtract them. So click Edit, go down here to IQR. Okay, right there. And so again, the results aren't surprising. All of these are measures of spread. The Cadillac is more spread out than the SAW. We expect every measure of spread to be larger for the Cadillacs, and it is. So this is saying that the distance between the first and the third quartile, or in other words, the range of the middle 50% is about 9,000. For the SAW, it's around 5,000. So Cadillac is about twice as big as the SAW, which again, you kind of expect. All right. Oops. All right. So here's the question. We have all these pros and cons. When do we use which, right? So here's kind of the idea. It's exactly the same as the mean and the median. When we have outliers or strong skew, we use the median. for the center, and we use the IQR for the spread. And again, even though we're losing the tail of the distribution, the reality is that that skew or that outlier is going to inflate the standard deviation. It's going to make the distribution seem wider than it really is. So we're going to use the IQR. When it's symmetric, we use the mean and we use the standard deviation. And that's what we're going to go with. And again, you might say, well, the median, the IQR is always the safe bet, right? But there's lots of reasons why we're interested in the mean and standard deviation whenever we can use them. We'll talk about it next week. But this is how we're going to decide which one to use. When in doubt, so very often distributions are not perfect. They have a little bit of skew. If you're not sure, compute them both. Or what we often do is we trim the 10% extreme values. The largest 10%, the smallest 10%, and then we recompute the statistics. If the standard deviation changes a lot, we know that there's significant skew, okay? So if after I trim the data set and I recompute the standard deviation, it changes a lot, that means that those extreme 10% were really affecting it. And I'm probably going to go with the IQR, all right? Okay, so why don't we take a real quick break? In the meantime, I'd like you to go to my lab and open up this practice problems. I want to work some practice homework problems, okay? It doesn't count for anything because it's not synced to Canvas, but this will help a lot with the homework and kind of get you more familiar with the commands, okay? So we'll take a little break and come back. Where's the flight? Does anyone know? Good, nobody knows. Everyone was paying attention. Great, all right. Okay.
Still right. Oh, they still need to lend that therapy. They lended the two boosters and not the main stage.
Oh, okay, I see.
Yeah.
That's pretty fucking neat.
Yeah.
It's like in unison. That's pretty fucking neat.
Yeah, the car's gonna go into. They're trying to get two boosters. So it's gonna go around the side and then like hit the.
It's fucking fun.
It's tomorrow, right?
The critter,
I will let it. I'm gonna go there, bullshit. Wow.
Oh, that one's there. Fucking drunk platform.
Yeah.
Exactly. Be retired special agent. That's what I'm doing. I really bought a house up there.
What fucking Russians on this beat?
The area about.
I don't know.
Oh, wait.
I bought a house up there. The area is cool.
I mean, that's small.
Jeremy, take the chance. Jeremy, take the chance.
Using this class.
I don't know, but it was I have no idea what. No, the break I shop was done on super small, okay, I just
Yeah, what's up?
And they finally came back, they said, yeah, the code was incorrect. So they asked me where I bought it from. I said from the school.
Right.
They said, okay, we're gonna have to send somebody to collect it, because apparently that's not the first time.
You know what might have happened? I think I know what happened now.
It's
that-
not your, it's the actual code that I bought.
Yeah.
Was bad.
So I think, well, I think I
They
know what
emailed
happened.
me a new code.
Oh, okay, so you're all good now?
Yeah, they gave me a new code right there.
And it works and everything, we're all good?
Today, they just sent it right now. They said that was like last, remember, they told me to call last Friday.
Exactly.
So I called them to open the case, and I had to wait over the weekend, and then they emailed me right now, so.
Good.
I'm gonna head out.
Okay,
Cool.
so, we're gonna have to kind of get you caught up on this stuff, so we'll sit down and talk about it, but I'm glad you're able to help. Okay, that's good news.
Sounds good.
All right,
Appreciate it.
thanks.
Thank you.
No problem.
Like, I have been like competition, I know everything about them.
You're sad. You went hunting.
Um,
You'd survive again.
I'm not, you guys are HS, that's the difference. I'm global
That is true.
Very different than what,
It's
yeah, so I'm not like,
you know, I do have people that did HS.
wow. I
$15.
You know what? Whatever, I'll survive and move on. My life is over.
All right. Okay, so everyone's found the practice problems? So let's go ahead and take a look at a few of them, okay? Okay. So the first problem says that it's giving you sales over 1 week that were collected for 18 stores in a food store chain. The data is shown below. The stores in the town, they're located in vary in size. Okay, so we're looking at the weekly sales for 18 stores from a food chain, and the first question asks us to determine which of the box plots of the data is correct. Okay, so easy way to do this, of course, is just to plot the box plot. Click here in StatCrunch and just open it up. If it's not opening up, what's wrong? Pop-ups. That's right. You gotta deal with the pop-ups. Go ahead and allow the pop-ups. And okay, so I'm going to go ahead. I'm just going to graph it using a box plot, right? And one thing to be really careful about is when you're plotting this with a box plot, the one thing that you have to do is you have to make sure that you check this little box here, the first box. If you don't, what will happen is StatCrunch will draw a line from the edge of the box all the way to the extreme values. So it won't identify outliers, okay? So we have to go ahead and check that box, and we do that, and we're good to go. All right. Now, I know some people's data sets are going to differ a little bit, so if you look at my answers, they might not be in the same order, but that's okay. Okay, so there's the data sets. There's the plot. Let me bring this over a little bit more and move this. Okay. So looking at my options, whoops. Which one of these options appears to be correct, A, B, or C? Which of these plots most resemble this? We can kind of eliminate some of them, right? Which ones can we eliminate right from the get-go?
D.
Okay, we can eliminate D. Any others?
C.
Okay, and why can we eliminate D and C? That's like low-hanging fruit, right? That sticks right out. So we have these two upper outliers here. We don't have them here. Now we look here. Which of these two are correct? We look at the box plot. Look at these two. And you can't see it. You can't see it too well on mine because it's kind of like dark colored, right? Oh, can you make the box plot? Yeah. Go ahead and make the box plot. I want you guys to practice doing homework. So when you run these little things about like, you know, oh, MATLAB's having a hard time doing this, or my MATLAB, you kind of know what to do. Okay. Yeah, that's kind of nice actually. It's a little added feature. Okay. So think about which one you think it is. Yeah, no.
StatCrunch still won't open. I don't know if you have any ideas of a solution.
Okay. You guys can work together for right now, though, right?
Yeah, I know the
Yeah, I'll take-
homework and stuff for the future. I was just wondering if you had any suggestions.
I'm gonna have to troubleshoot. Let's go and we'll take a look at it after class. We'll kind of get to the bottom of it, okay? All right. So how do I know which one of these last two it is, B or C? What's the relevant feature here? The median here, I notice, is right in the middle of the box, right? This is symmetrical. Here it's not, okay? So I'm going to clearly choose A for that one. All right. Now sometimes they'll draw it so that the boxes and the medians are the same. Then you have to look at the whiskers, right? So you keep on trying to look at the finer features, whatever you need. All right. So we think it's A, and we done good. So now it wants to summarize the central value for sales for this week with the mean and the median. So let's go ahead and compute them first, okay? So I'm going to go up to Stat and Summary Stats, right? Columns. And the mean and the median. I'm going to compute them both. Okay? And it's asking us to round them to the nearest dollar. So notice you can just copy and paste, all right? You can copy this. And when I round this off, I'm going to have to round it up to 6. And again, yours are going to differ a little bit probably. Okay. And then just copy and paste the mean. Okay. So now tell me, why is it that the mean and median differ? So let me see, I'll call on you. I got my red dot on you. Why are the mean and median different?
Because
The outliers. The outliers are pulling it up, right? So what's happening here, we know that whenever we have skews, whenever we have skew or an outlier, it's going to pull the mean, and that's what's happening, right? So you can see that the mean's getting pulled higher here. So we're not going to use the mean, right? And that's what's happening. So we're going to say that the mean is higher because the outliers are going to pull it up. We know that's going to happen whenever we have skews or outliers. All right, great. And so it says which one of these are going to do a better job of summarizing the store's sales. So you have the mean and the median. Which one do you think you're going to use in this case? I'll call on you. The median. Well, okay. Why the median? Right. Exactly. So we know that because the mean's being so strongly influenced by those two values, whenever we have skews or outliers. So if you go back to actually this part of the PowerPoint, right? This part of the PowerPoint's kind of telling us what to do. When we have outliers or skews, we're always going to use the median, right? Good. All right. So we're going to use the median because of distribution. Whoops. Has outliers. Good. All right. So we want to summarize the spread. So now we want to go ahead and compute the standard deviation and the IQR. And again, it's easy because all we have to do is say edit options and then just change to standard deviation and IQR. Now be a little careful. There's also a thing called the standard error. We're going to talk about that later on. That's not the standard deviation. So you want to be careful which one you check. The IQR is way down here. And we say compute. And there are our values, okay. Now, let's see. So we're going to go ahead and compute. We're going to put the standard deviation. Again, be careful. It says round it to the nearest dollar, right? So make sure that when you round it, it's done correctly. Okay. And the same thing for the IQR, which is just... And again, I think your values are going to be different than mine, right? You have different data sets. And that's okay as long as you're able to get it to work. Okay? Good. So everybody's good on the IQR and the standard deviation? So what's going on with that? They want to know, given what you know about this distribution, i.e. that it has outliers, which measure is going to do a better job? What do you think? IQR or standard deviation? For exactly the same reason, right? We know that when we have outliers, home base is getting pulled up. That's inflating the standard deviation, okay? So whenever we have outliers, the standard deviation appears larger than the real width of the data set. Good. All right, one more. So it says if we were to remove the outliers, how would you expect the mean, median, standard deviation, IQR to change? So let's think about this for a second. So if I remove the outliers, what will happen to the mean? Nothing's going to be drawing it out, right? So it's going to decrease. So we would expect the mean to decrease, right? What would happen to the median if we took out the two outliers?
It would stay about the same.
It's going to stay about the same, right? Because again, the median doesn't look at the outliers, right? So it's going to be roughly about the same. Good. What about the standard deviation and the IQR? If I take out the outliers, what's going to happen to the standard deviation? It's going to go down, right? Because the outliers are inflating it. Again, the IQR doesn't see anything with the outliers, right? The IQR is going to be unaffected. So this kind of points out why we like the median and the IQR. They're not going to be affected by just a few lone data points, okay? So let's see, the median and IQR. Let's see, so the mean and the standard deviation would decrease. There we go. The median and the IQR are relatively unaffected. All right, good. Okay, next question. So here we're given the ages that were obtained by a demographic study of some marketing team, right? And we don't usually look at data values like this. This is a really weird way of running a data set, but they're just trying to get all the data values in, right? Of course, it's not going to matter to us because we're going to open it up in StatCrunch anyhow. So we click here, StatCrunch, and all we want are the quartiles. And that's easy. So we're just going to say stat, summary stats column, click on the variable, and say Q1 and Q3. Scroll down here. There we go. Compute. Okay. And there's our two values. So you just go ahead and enter them. So, quick question. What's the interquartile range here?
9.
It's going to be...
Oh, it's
Yeah, right. It's going to be whatever your data says. It'll be Q7, right? So for me, it'll be 10. For you, it'll be 9. That's right. Just take the Q3 minus Q1. Good. Okay. And we check. And we done good. All right. And we're not going to worry about Tukey's method. So Tukey was an American statistician. He was very influential. He had another way of doing quartiles. We're not going to worry about it. So I won't test you on that. Okay. He was the person who was actually kind of responsible for people making box plots, and he introduced it. That's why he has the right to define his own quartile. All right. So here's our data set. Pretty small, but we're going to do everything in StatCrunch, and we can compute the range, the variance, and the standard deviation all at one fell swoop. All right. Open it up. And one of the things, I like about StatCrunch, and one of the reasons why I like to employ it, is because it really is easy to do calculations. If you had to open up all these data sets, even in Excel, it gets kind of cumbersome. And the variance. And there we go. And go ahead and enter the values. If you run into any problems, let me know, okay? This is kind of the idea. I want to make sure everyone's good and we're getting practice on this, okay? Again, be careful when it says two decimal points, it's not kidding, right? And you have to round it off properly. Okay? And finally, standard deviation, 2 decimal points. Okay. And there we go. Everyone's doing okay? Let's see. Sample variance. Oh, it's way up at the top. Yeah, I know it's easy when you miss it. Yeah, right there. It's right there. Standard deviation. Yep. Good. Okay. We're not going to worry about that, so we'll do it. Okay. It's okay. That's all right. It's a real kind of slight deviation. Looking good? Yeah, all right. And so you guys are already on the next one, so excellent. All right, good. Okay. So the homework will be a piece of cake. All right. Same sort of thing. We're just basically computing the same things, right? Just to get a little practice. Okay, there's our variable, variance, standard deviation, and range. By the way, you can compute everything at one time. If you take the thing and just swipe it, it'll compute everything. What will happen, though, is it'll give you this huge, long row, and it's actually hard to read. So I tend to just compute what it asks. Okay. Again, your mileage will vary because you'll have different data sets. All right. Okay. All right. Everyone ready for the last problem? Let's do it. Okay, so a published human development article showed life expectancy by country for 2 continents, okay? And what it wants to know is it wants to know which continent do you think has the larger standard deviation. So let's just look at mine so we're all on the same page, okay? So the first thing we want to do is we kind of want to look at this data set and make sense of it. One of the things that you're going to find when you look at data sets, like on that one homework set and on the quiz in a table, right? You got to stop and kind of slow down, right? So this is continent A. These are the countries in continent A, and these are the corresponding life expectancy. So the 14th country in continent A had a life expectancy of 80 years. These are the countries in continent B and the corresponding life expectancies. Now, looking at just these values, which country do you think has the larger standard deviation for life expectancy? What do you think? Go ahead. You just kind of look at these values. Look at these values and these values. Which should have a larger standard deviation, do you think?
I think A.
Okay. And why A? What's making you think that?
I think the number, the range is kind of large.
Okay, so the question is, what is the range here? So notice that I would kind of disagree. How many people think the range of B is larger? I kind of think the range of B is a little bit larger. So you kind of have to look at it, and I know it's on the board, right? But if you look at this, this is like 48, this is like 64, right? It looks like these values are maybe a little more spread out than this. These are all kind of clustered around the low 80s, kind of, right? So because this has, now it seems to have, we have to verify it, right? But this seems to have less spread, so the thing that measures the spread, the standard deviation, we think will be less. But let's just check and see, okay? But that's kind of the idea. Now, it isn't always necessarily true that because the range is larger, the standard deviation is larger. That's not a mathematical fact, but it tends to go that way. Okay, so let's see. So we'll open this up in StatCrunch. And if we're going to answer this, I would probably say that B has the larger standard deviation because it seems like there's a bigger range, right? Okay, but let's just check and see. So now let's just go ahead and compute them, all right? Summary stats column. We choose both variables, right? And compute the standard deviation. And let's see what happens. And sure enough, we see what we would expect, right? So the life expectancies for continent A is in variable 2, and that's a little bit less. So let's go ahead. We'll finish this guy out. So one thing to be careful of: always read the problem carefully. Part of reading the problem carefully is look at how many decimal places, right? That can really kill you, especially on a quiz. You work real hard, you get the decimal places wrong, and then it screws you up, right? Whoops. Okay. And the standard deviation for B is 4.65. Thanks. So the standard deviation for B is larger than A. Okay. And we're done. I know, a lot of hard work. I know. All right. How's everyone doing? And so part of it's just kind of learning how to enter things too, right? Making sure that you're doing things like that. Great. Any questions on that problem? Any difficulties? So here's the last thing I want to do, just to kind of wrap up for today, okay? Is I want to go back to, I'm going to switch gears, the last thing we're going to do today. So one of the things that we want to do, remember the entire point of chapter 3 is we wanted to learn how to describe plots. So now we're totally done. We can describe both of these, right? What do I need to describe for the Cadillac? So the Cadillac, kind of looks like this, right? Long tail here. How would I describe the plot for the Cadillac? Your boss says, okay, Johnson, you looked at the Cadillac data, what is it like? What do you say? How do you describe it?
More spread
But just the Cadillac, so that's actually a good thing. We might want to compare them, but just looking at the Cadillac for the time being, how would we describe it? What is it that we describe?
It's right.
I'm sorry?
The skew.
So the one thing we have to describe is the shape, right? So how would you describe the shape?
It's right skew.
It's right skew, that's right. It has a tail, the tail's to the right. Good. What else do we have to describe? So we have to give the measure for the center, right? We have to describe the center. How are we going to describe the center of this data set? We've got two choices. Which are they?
Median and
the median and the mean. Which one's better in this case? Or can we use either one? What do you think?
It depends on what you're looking for. But for this case, it would be median because there's a skew.
That's right. So remember what the center is. The center is the value that most of the data values are centered around. So when you have skew, notice that this value, this is the median, more of the values are centered around it, right? So when we have outliers or strong skew, we always use the median. Good. What else do we have to report? So we have to tell the number of modes, right? How many modes do we have here? It's a little tricky. Most people would say unimodal, but there is kind of a question about what's going on out here. There might be different models, right? There might be a little subpopulation. I would probably say unimodal, but you might want to investigate that. And if for no other reason, just because the other mode is so small, it's not such a big deal. What else? Two other things we have to tell about.
If there's outliers.
Right. The book actually has a really nice way of putting about it. The book says something like unusual features. Okay. But usually the unusual features are outliers. Do we have any? What do you think? Any outliers? How can we tell?
It's separated from the rest of the plot.
Let me ask you a question. Are these data values outliers here? What do you think? There's a difference between outlier and extreme value, right? So you can have a distribution that has a really long tail. These are extreme values, but like you said, if it was an outlier is like an outcast. It's outside. They'd be like a big gap, right? And then they'd be by themselves. So there are no outliers. And what's the last thing? We've been working on it all period. The spread, right? So what would we give for the spread here? What would be a measure for the spread? We use the range, the interquartile range, for the standard deviation. The interquartile, right? Because we have strong skew. Okay, so if we wanted to describe this, we would say that it is unimodal and right skewed with no apparent outliers. The center is given by the median. With a value of, and now we have to go back and actually compute it. What was the median for the Cadillac? So I'm going to go back and take the IQR, the median, hold on, the mean, standard deviation, the IQR, and we're done. Okay. So the median's about 38,500. And a spread given by the IQR of about, we said what, 9,000 and change, 9,200. Okay, and that's how we would describe it. So if on a quiz, on an exam, I asked you, you would report these 5 things, and then you'd write out a little summary like that. Okay. And so you can kind of see that in your mind if you think about it. About 38,500, you can see a kind of long like tail. Okay. Good. What would we do for the sob? How would we describe that? The sob looked more like this, right? So it's still unimodal, right? It's symmetric. It wasn't perfect, but it's pretty close, right? So it's approximately symmetric. No outliers. And right, for the center we can use the mean now because it's symmetric, right? So we use the mean. And for the width, what will we use? Go ahead and finish it out. Got the IQR, standard deviation. What do we use when it's symmetric? Standard deviation. And so you'd write up the same sort of thing. Okay. You say it's unimodal and you would say it's unimodal and approximately symmetric with no outliers. the center's given by the mean. That's approximately 30,000 or 29,500, and the spread's given by the standard deviation, which is about 3,500. You can put the exact values, but usually when you're talking to people, if you can round it off to something that they can easily grasp, it's 3,500 is better than 3,400. $93 or something like that. All right. So now we're totally done with the descriptive part. We got through the question, the data collection, the description. Now we're going to start on probability models, and we're going to see the standard deviation is the link. That's the thing that's going to let us do with that. All right. That's all till Thursday. So thanks a lot. And if you need help on the activity, Soraya's having a supplemental instruction in your College of Arts and Sciences from 6 to 7:30 tomorrow. Okay. And of course, I'm always available. All right, thanks a lot.
He has a list. What's going on? You're going off the list for the activity one, right, sir?
I'm sorry?
To make for the group?
Yeah, but make sure that you put everyone in your group's name, just because it's easier for me.
You don't know everybody's name. You don't know the last person.
Oh yeah, I think I posted it.
Okay.
Yeah, I put that on the announcements. Yeah, so you can figure out. Does that make sense?
Yes.
Okay, good.
So it's Catherine and Elliot, and I just put them to another.
And then you wanted that one by tonight?
If you can do it, if not, you can do it by Thursday. Nobody will die, but just to kind of get it done.
Hey,
Yeah,
question. I was
sure.
in Cassidy and Elliot's group last week. She emailed me, but she didn't know our names of the other two people.
You know what? I got them actually. If you go to the announcements, I posted like a list of everyone.
Okay.
So if you look on that list of announcements, you can kind of pick out who's who.
Okay, so just go ahead and email them that then?
That'd be great.
sounds
Okay,
good.
thanks. I appreciate it. Yes, sir.
I did the supplemental instruction yesterday,
Uh-huh.
and actually finished off the group one project.
Good deal.
But the other two people that were in my group were from your morning class.
So how did you guys do it? So you sent it.
We all went to the supplemental thing, and
Right.
the lead of the group sent you an email with all of our names CC to it.
Excellent.
Also, all the names were on it. I think we did mention something, the fact that I was in the afternoon class and they were in
Great.
the morning class.
That's okay, because you guys are all in one big roster on the grade book, so that
Okay.
works out perfect. I appreciate it. Thanks for letting me know that.
Well,
All right. What's up?
Sir, I can't get StatCrunch.